Ready? Recording.
So today we're going to talk about voltage, current, and resistance. Can you explain any of these things? What they are? Voltage, current, and resistance?
Resistance is resistance to electron flow, current is flow of electrons, and voltage is potential difference.
Yes?
VIR is the
Yeah. So voltage, current, and resistance are the fundamental blocks in electronics. So electroengineering is all about voltage, current, and resistance. So if you have a system with this voltage, current, and resistance, what is moving in this system? Do you have any idea?
Current.
Yeah, but the current is made of,
Electrons.
yeah, right, electrons. So do you know what is an atom? It's made of electrons, neutrons, and protons. So we can measure these electrons, this flow of electrons. So this is the current. The electrons flowing is called the current. So these electrons, they need motivation to move around. So the voltage is called exactly the motivation that the electrons need to move around. So the amount of voltage you give them, if you give less voltage or less motivation, you have less electrons to move around. And if you have more voltage, you have more motivation for them to move. So you can also measure how many electrons are moving. And so let's make an analogy. It makes easier to understand. So if I offer you like 10 cents to do a lap around the whole campus, would you go? No. And if I offer $10, would you go? No, not yet.
Sure.
And if I offer, let's say, $1,000, how many of you would go? So I can stand here and count how many of you would do this lap. So I'm counting how many electrons would move with this motivation I'm giving. So if I don't say like how the lap is, would you go anyway? I don't say. I mean, I just say it's around the whole campus, but how this lab is, you don't know. Would you go? So if I say we have a lot of obstacles in this lab, would you go for $100, the same lab? So you start to think about going or not. So this is the resistance. So it's gonna make easier or more difficult for you to move. And then this is how the electron chooses how when to move or not. So less electrons will move or more electrons will move. So this is what decides actually how much current flow. What is the electrons? So how much voltage I provide to these electrons, and the task they have to do to complete their job, which is the resistance. So voltage and the resistance will define the current. So I have this relationship here between V, I, and R. Do you know what this is?
Not Ohm's law.
Yeah, this is called Ohm's law. It's voltage equals to current and plus times resistance. So with this function, you can find the current you have when you have this specific voltage and the specific resistance. So let's draw. So a source of voltage is, for example, who can give me a source of voltage? Yeah, the battery is a source of voltage. I can draw a battery here and then connect, for example, to a resistor here. So if I say this is, for example, 2 volts, and this is 2000 ohms, which is 2 kilo ohms. So how much current would you have in this case? This is 2 volts and this is 2000 ohms. Yeah?
4,000?
4000. This, you can use this rule to find the current. I have the voltage and I have this resistance. So how would you say?
It's 1/1000th of an amp.
How many?
1/1000 of an amp.
1 over 1000?
Yeah,
Yeah, which is 0.001,
Yeah.
right? So I'll have the current here will be 0.001, which is called amps. This is the unit of current, amps. This is the symbol, I. And this is called 1 milliamp. So this is 1 milliamp. So if I hold, for example, a battery here on my fingers, so let's say this is a 2-volt battery. So do you think that current would flow around me, like my body, if I hold this? Like, do you have a battery?
We have a lot of Oh.
Let's say this is 2 volts. Yes, this is 1.5. So if I hold this like here, I think that there's current here flowing.
Yeah.
Yeah. So there's no such a thing that's like no resistance on it. Everything has some resistance. So my body has a resistance, and if I hold this, this is the voltage, and then I'm the resistance, and then I'm gonna have this current. So if I have like my body is, let's say, 2 mega ohms, which is all these zeros. My body is 2 mega ohms, let's suppose. So how much current would flow if my battery was 2 volts? Yeah, in this, so I'll have 0.00001. Is that it?
Yeah.
Amps through my body, which is 1 micro. And the symbol is mu. So 1 microamp. This is not enough current to make to do some damage on me. So I'm fine with that current. But if I have like a wall outlet, for example here, let's say, and I touch this side and this side of the wall outlet. So what would be the voltage here? Yeah.
120.
Yes, 120 volts. And then my body is 2 mega ohms resistant. So how much current would flow in this case? Do you have a calculator or it'll be 120 divided by this 2.
I think it's 0.3 zeros and 6.
Yeah, that will be like uh, 0.0006.
He says it's
One more,
4
yeah,
zeros
we'll
here.
see 1 0. So x, which is 60 microamps, which is 60 times this current. So this can make a damage on the neck. So don't do that, please. So for today, it's it. So that's it. I have this Ohm's law, which is really important in electrical engineering. It's all about this voltage, current, and resistance, and it's a simple rule you can always use to find these values. So, do you have any questions? Do you know what current, voltage, and resistance are? Okay.